Good evening, Lamai. Right, let's start the session today. Right, today we are going to discuss about organic conversions. That means the organic compound synthesis, right? So I hope all of you got the tune, right? So let's start the session, right? It is all about making new organic compounds, right? From the available very limited amount of organic compounds in our laboratory, right? We are supposed to come up with new organic compounds, right? There we can use any kind of inorganic reagents, right? So with the use of inorganic reagents, right, we are supposed to here form new kind of organic compounds from the available very limited amount of organic compounds in our laboratory, right? Basically, in most of the practical usages, right? When you are to synthesize chemicals in regard to even the medicine, the models of the medicine are created with these techniques, right? Compound synthesis. You all of you know that, no? Most of the medicines comes as organic compounds, no? Right? So to synthesize these those compounds in medicine, right? Basically, we use this technique, right? Right. So let's start, right? So first of all, I'll start with the reactions, right? What we have learned so far, right? No, mostly the reactions involved in the hydrocarbons. So actually, we have completed the discussions of alkenes, and alkynes, right? And the production techniques as well as the right reactions of them. So quickly, we'll go through those things, those reactions, to start this thing, right? So those are the most important stuff, right? When it comes to chemical synthesis, right? In A levels, right? Let's come up with the reactions we have learned so far, right? So I'll start with the note number 1 in your tute, right? It is about the alkenes and their reactions, right? So I have named the topic, right? The topic number 1 or note number 1, right? As note number 1 is named as bromine OH and the phi bond. I just gave it a name, right? That's all, right? Br OH and the phi bond and the carbon phi bond. Carbon phi bond. That's just the name given to that, right? First of all, let's discuss about these reactions we have learned so far up to now, right? So if you are with an alkene, if alkene is available in your laboratory, right? Let's see. If you are with this alkene with you in your laboratory, you have this alkene, right? Then actually instead of this phi bond in your alkene, right? You can come up with various compounds. Last day we have learned those things, right? Last few weeks, right? We have came through these, right? So instead of this phi bond, right, you can add BRs, OH groups as well as hydrogens, right? By removing these phi bond, right? So it's like this. So you can convert this phi bond into 2 hydrogens, right? You can convert that phi bond into 2 hydrogens like this, 2 hydrogens. So basically you can come up with a come up with the alkene, starting from a alkene, right? To do so, what we need these reagents. You have to add the H2s to getting rid of this pi bond and coming up with two hydrogens. You can add H2 with nickel catalyst or H2 with platinum or H2 with palladium catalyst. Any one of these reagents will give you the alkane, right? So instead of this 5 bond, you can add kind of a HBr bond 2. You can come up with a HBr molecule, right? You can come up with the Markovnikov style or anti-Markovnikov. The Markovnikov means you're supposed to add the hydrogen to the carbon with most number of hydrogens out of the carbons of the 5 bond, right? You can add the hydrogen to the carbon with most number of hydrogens, and you can add the Br to the other carbon. So this is the Markovnikov style, right? So you can come up with the Markovnikov style of addition of HBr to alkenes by just adding HBrs to your alkene, right? So what else? So you can add the HBr molecule, right, in the anti-Markovnikov style as well. Anti-Markovnikov. That means the H is added to the carbon with low number of hydrogens. Here only one hydrogen. Here you have two hydrogens. So H is added to the carbon with low number of hydrogens. Right? Like that also, you can add the HBr, right? The anti-Markovnikov way of addition, right? So let's write it like that. The anti-Markovnikov. Right? For that, not only the HBr, but also some other reagent, the R2O2, organic peroxides are also needed, right? So the reagent is R2O2 with HBr, Br with R2O, right? Instead of this 5 bond, you can add some H2O molecule too, right? You can add some H2O molecule too, right? So like this, getting rid of 5 bond and adding some H2O molecule in the Markovnikov way, right? Adding the hydrogen to the carbon with more number of hydrogens, and to the carbon, the other carbon, you are just supposed to come up with the OH to add the H2O molecule. But to add some H2O molecule, what you need as a reagent, you need to supply some water, and there you need the help of the H2SO catalyst as well, right? So that the reagent is going to be diluted H2SO4, or one can say DILH plus. Diluted acid is used to come up with an H2O molecule, right? The H2 molecules and HBr molecules are normally added as the as the Markovnikov way, right? Only the HBrs can be come up with the anti-Markovnikov like this as well, right? So what else? Basically, we can add some two bromine atoms, right? Instead of the 5 bond, as well as we can add two OH atoms, so OH groups instead of that 5 bond as well, two OH groups, right? Dibromo products and dihydroxy products. So to add two BRs, what we need to add is just the Br2. Br2 is some non-aqueous medium, Br2CCl4, better. Or you can come up with Br2 liquid. Sorry. To add some two OHs instead of the 5 bond, you can come up with the cold dilute basic KMnO4, called as a basic KMnO4. this kind of oxidation, so can be done by the KMNO4, but these conditions should be used, right? Then not only the addition of HBRs and H2Os, you can get rid of those HBRs and H2Os to reform the alkenes as well, right? You can get rid of those things, right? So I'll write that thing like this. So some H and Br can be removed, eliminated to form the alkene again, right? To do so, the reagent we need is the alcoholic KOH. With the use of alcoholic KOH, you can produce the alkene again, starting from the alkyl halide, right? So H from the adjacent carbons, the hydrogen from least hydrogen containing carbon will be removed with the Br to form the pi bond, right? That is the elimination rule now. When you have to add some HBr, the hydrogen is given to the carbon with high number of hydrogens instead of a double bond if you have to add HBr, right? If you need to produce an alkene double bond, by getting rid of HBr, the hydrogen will be removed by the adjacent carbons of halogen, right, containing carbon, right? But from the least hydrogen containing carbon, the hydrogen is removed, the halogen adjacent carbons, right? So that is the elimination rule, right? So getting rid of H2O molecule to come up with the alkene, right? We can use actually two reagents. Normally we can use concentrated H2SO4, that is one reagent we can use, concentrated H2SO4 and some heat, or one can come up with alumina, AlO3 and some heat. One of those reagents can be used to getting rid of H2 molecule to produce the alkene, right? This is the summary of reactions. This is kind of a summary of reactions with alkenes, right? So all of these, right, we have learned with alkenes, right? These are very important to carry out your conversions, right? Okay. Few more reactions are needed at the first stage, right? So we'll discuss those things as well. So basically, you can produce some triple bond. You can produce some triple bond from, right, these dibromo products. If two BRs are appearing on adjacent carbons, right, you can remove two of HBr molecules to come up with the two 5 bonds, ultimately to produce the, right, triple bond here. So let's write that thing as well. Okay, so come up with the triple bond like this. Triple bond between the two carbons which earlier bear the two halogens, right? That can be made by removing two HBr molecules, right? So for that, alcoholic KOH can be added, right? The same reagent which was used to remove the HBRs from here as well, right? What else we can do? So basically, right, we can add some H2O molecule to these alkenes as well. Not only for the alkenes, but also for these alkynes, sorry for that, those alkynes, but also for those alkynes. With those alkynes, we can add some HBRs, right? This kind of alkyne, right? Major hydrocarbon. To these alkynes as well, we can add some H2Os. We can add some H2O molecules. To do so, right, what we need is just to add some H2SO4 or dill acid. Normally, to add some water molecule, you come up with dill acids, right? So here, as the reactivity of alkynes are less than the alkenes, we need some more catalyst to do the process. So if you add some, right, Hg2 plus catalyst with the DL2SO4, you are able to convert these alkynes to aldehydes or ketones. So basically here you come up with the respective ketone, right? Respective ketone will be produced, right? Like this. So that is a ketone, right? That can be done with the use of Hg2 plus DL2SO4, right? So basically these ketones can be used to produce the alkanes again. These ketones, right, as well as these alkynes, both can be used to produce those alkanes again, right? So how to produce alkanes with the use of ketones and aldehydes? It's the Clemmensen reduction. It's the Clemmensen reduction, right? You remember that? It's the Clemmensen reduction, right? Using the Clemmensen reduction process, what is the reagent for the Clemmensen reaction? It is the zinc amalgam, with conc H2SO4, sorry, with conc HCl, zinc amalgam with conc HCl. I write it like this. Right? That is a Clemmensen reduction that can be used to produce the alkanes from the aldehydes and ketones. So see, these kind of relationships are there, right, with these reactions. What else you can think of, right? So these alkynes also can be converted to, I mean, this reaction arrow is not there in your note, just write that thing as well. These alkynes also can be used to, right, produce the alkenes, right, that is used in the H2PD with the barium sulfate and quinine, right? If you add some H2PD with the barium sulfate and quinine, you can convert the alkynes to alkenes, right? So H2PD with barium sulfate and quinine. Right now? So with that manner, right, you can convert the alkynes to alkenes. These are some summary of reactions we have learned so far, right? All of these things we have learned up to now, right? What else we have learned? I think it is all, no? We have learned up to now, right? But again, I'll write 2 more reactions here. I'll write 2 more reactions, right, regarding this this thing, right? 2 more reactions. So these are 2 new reactions, right? I write those things, right, here. 2 new stuff, right? These 2 are new reactions. So you can convert these alcohols to aldehydes and ketones, as well as the aldehydes and ketones can be converted to alcohols. These conversions can be done, right? Okay, so you can convert the alcohols to aldehydes and ketones, as well as aldehydes and ketones can be converted to alcohols as well, right? These are alcohols, no? These are aldehydes and ketones, right? Let's see how to do this thing. So basically, going from here to here, right? What happens is, going from here to here, what happens is, actually, you can see, right? If you have to concentrate on this carbon, that is the carbon which had undergone the change, right? Which has undergone the change, right? This carbon. So here we can clearly see, right? These 2 hydrogens have removed from this compound. These 2 hydrogens have removed to come up with this thing, and some double bond had been formed. Some double bond has formed by removing these 2 hydrogens, right? So that is referred to as a oxidation. Carbon-oxygen bond is formed by removing carbon-hydrogen bonds. Removing carbon-hydrogen bonds, you have formed a carbon-oxygen bond to come up as this compound, right? It's an oxidation. So you can do this process by using some oxidizing agents. Right? So PCC, that is such a compound, right? PCC is referred to as a oxidizing agent. So it is PCC means it is actually pyridinium chlorochromate, right? Pyridinium chlorochromate, right? So I'll discuss that thing later in the session, right? With the note number 2, I'll discuss more about the PCC, right? So PCC is kind of a reagent, pyridinium chlorochromate. Pyridinium chlorochromate. It's a chromate, right? Chromates, the dichromates are referred to as good oxidizing agents, right? So you can use this oxidizing agent to convert this stuff to here, to getting rid of carbon-hydrogen bonds and form some carbon-oxygen bonds. A new reaction you are going to learn here, right? Another one, this one. This is actually the opposite of the earlier case. The opposite of the earlier case, right? Here what has happened? Basically, you had removed some carbon-oxygen bond, the double bond here, the carbon-oxygen bond is removed and carbon-hydrogen bonds are formed. Carbon-hydrogen bonds are formed when converting this thing to here. Carbon-oxygen bonds are removed and carbon-hydrogen bonds are formed. So that is kind of a reduction, right? So to do that reduction, to add some hydrogens like that to these polar bonds, to add some hydrogens to these polar 5 bonds, normally we go for a reagent called as lithium aluminium hydride. Lithium aluminium hydride. So lithium aluminium hydride is the reagent we use to hydrogenate the polar 5 bonds. Polar 5 bonds. Earlier we had hydrogenated the non-polar 5 bonds. To hydrogenate the non-polar 5 bonds, right? To add some hydrogens to the non-polar 5 bonds, we normally go for H2 nickel, palladium, or platinum, like that with H2. But to hydrogenate the polar 5 bonds, these are polar 5 bonds, right? To hydrogenate these polar 5 bonds to come up with 2 hydrogens, right? So we go for a reagent called as lithium aluminium hydride, a new one, lithium aluminium hydride. The hydride ions are the ones which will be donated to those compounds. The lithium aluminium hydride, right? We'll discuss those things more with the theory lessons, right? So lithium aluminium hydride, a new reagent, right? Lithium aluminium hydride. Normally that thing will be used, lithium aluminium hydride is normally used with dry ether medium, and with some acidic makeup, That is how that reagent is used, right? Lithium aluminium hydride is used in dry ether medium with some acidic makeup, right? So we'll discuss more about that thing later, right? So that is the reagent we use to convert these aldehyde ketones to alcohols. The double bond oxygen bearing carbon will convert to a OH bearing carbon, right? By adding 2 hydrogens to this carbon oxygen 5 bond, right? So we are supposed to use kind of a reagent which will hydrogenate the polar 5 bonds, that is lithium aluminum hydride, right now? So just complete that stuff and complete the whole diagram here. Right? Just complete the whole diagram. So you can do this one as well if you wish, right? So you can convert the alkynes also to alkenes, right? That is simple stuff, right? You know the stuff, right? So basically by adding H2 nickel, H2 Pd, and H2 platinum, right? So hydrogenating the stuff, right? H2 nickel, OH2 platinum, H2 palladium, no? Right. Just complete the table. You may have to write these 2 arrows, right? This arrow and this arrow, right? Just complete quickly. This reaction scheme is very important, right? This reaction scheme is very important to do our compounds in these processes, right? These are the basic stuff. Just complete the section. So after completing, we'll do some conversions. We'll do some simple converting stuff using these reactions. So keep it in mind, the anti-Markov thing can be done only by the HBr, right? Anti-Markov additions can be done only by the HBrs, right? You can't do the anti-Markov additions from the H2Os or any other compound, right? So anti-Markov thing can be done only with the use of HBrs, right? You can't do the anti-Markov with the HCl, HI stuff, right? As well. So only from the HBrs, the anti-Markov is allowed. Adding the hydrogen in the opposite manner as the Markovnikov rule is allowed only with the HBr, right? Remember that. මුලින්ම ඔය හතර ලියලා දෙන්නකෝ මට. මොනවද? හැදෙන්න ඕන ප්‍රොඩක්ට්ස් ටික කියලා. හැමතිස්සෙම කන්සන්ට්‍රේට් කරන්න ඒ කියන්නේ රියැක්ටිව් කාබන්ට. එයාගේ වටේ තමයි මොකක් හරි සිද්ධ වෙනවනම් සිද්ධ වෙන්නේ. හරි? රියැක්ටිව් කාබන් වලට කන්සන්ට්‍රේට් කරන්න. ඒගොල්ලෝ වටේ තමයි මොකක් හරි වෙනවනම් වෙන්නේ. අනිත් උන් ගැන හිතන්න එපා. Don't think of the other carbons. Always think of the reactive carbons. Reactive carbons කියලා කියන ළමයි අර මේ alkane carbon ලා නැතුව වෙනම තියෙන කට්ටිය. Alkane nature එක නැතුව if you have some polar bonds appearing or carbon 5 bonds appearing, those are referred to as reactive carbons. The carbons only with the carbon hydrogen bonds and the carbon single bonds, those are actually non-reactive. Reactive carbons are the carbons with carbon polar bonds as well as carbon 5 bonds. So concentrate on those. Then you can think of the change by thinking of the reagent you are using. Right? Just come up with the 4 things here. Right? එකක් දෙයක් කරමුද? Right, it's like this now. So මුලින් මෙහෙම ඉදන්න. So you are adding alcoholic KOH. By adding alcoholic KOH, right, what you are supposed to do? The alcoholic KOH is added to remove an HBr molecule from the halogenated hydrocarbon. From the alkyl halide, the halogenated hydrocarbon, to remove an HBr molecule, you are adding the alcoholic KOH. Just think of that. Alcoholic KOH is added to actually what? To remove HBr. That is the purpose of adding alcoholic KOH. So let's try to remove the HBr. Right? So Br will be removed. Br will be removed by with a hydrogen of adjacent carbons of the Br connected carbon. Br will be removed with one of the hydrogens, right, of adjacent carbons to the Br connected carbon. This is the Br connected carbon. These are the adjacent carbons. From adjacent carbons, one of the hydrogens will be removed. So which one to remove? This one, or this one? So this is the elimination rule. Eliminating HBr. Elimination rule. For that, the hydrogen will be removed. From the adjacent carbons, which contains least number of hydrogens. So one of this hydrogen will be removed. Here only you have 2 hydrogens, here 3, with this carbon is free. So from this carbon, one of the hydrogen will be removed. So that your 5 bond comes to here. So your 5 bond comes to here. So that is your new compound. That is your new compound, right? So I'll write it here. CH3, C, right? This CH3 is there. That hydrogen will be removed with the Br. So a double bond will form. And after removing one of the hydrogens here, that carbon will contain only one hydrogen. And the CH3 is there. Right? That is how we are supposed to think of the reaction. Right? Let's concern about this thing. So concentrated H2SO4 is added. What is the purpose of adding concentrated H2SO4? So basically we need to heat the stuff, right? What is the purpose of adding concentrated H2SO4? It is added to remove kind of a HBr molecule. Remove H2O molecule. Remove H2O molecule. To remove H2O molecule, we are adding concentrated H2SO4. That is the purpose of adding concentrated H2SO4 to these alcohols. So that this OH will be removed. This OH will be removed with a hydrogen from the adjacent carbons of OH bearing carbon. One of the hydrogens of adjacent carbons of OH bearing carbon. This is the OH bearing carbon. These are the adjacent carbons. The adjacent carbons of OH bearing carbon will be removed. One of the hydrogen, right? So here you have 3 hydrogens. Here you have 3 hydrogens. With this carbon, you have only 2 hydrogens. So that hydrogen from this carbon will be removed. That is the elimination rule. Elimination rule says when you are eliminating some HX kind of a molecule, HBr or H2O kind of a molecule, the hydrogen will be removed by the adjacent carbon which contains least number of hydrogens. Right? So that is this. So when this hydrogen is released, that carbon-carbon 5 bond will be formed here. When these two guys are lacking of a bond, by removing the stuff there to come up with the 4 bonds, they will form the 5 bond here. Right? So the compound is, then you have the CH3, CH. Only one hydrogen will remain because one is removed with the OH. So double bond comes to that place, right? And C, the OH is removed and 2CH3 goes. Right? No? Just check. See this one. Here you have added some Hg2 plus DIL-H2SO4. So Hg2 plus DIL-H2SO4 is added. What is the purpose of that? Adding the Hg2 plus DIL-H2SO4 for alkyne. Adding that into alkyne. What is the purpose? It is to add some H2 molecule. Purpose is adding some H2O molecule. So DIL-H2SO4 is added to add some H2O molecules. Consider H2SO4 is added to remove H2Os. DIL-H2SO4 is normally added to add H2Os. DIL means more water is there. More water is there. So more water is used to add those water molecules to your organic compound. Consider H2SO4 means your lack of water there. So water will be released from here to here because this guy is lack of water. Water will be released from here to here. Here you have more water. So water will be given from this one to here. Right? So you are supposed to add some water to alkyne. Right. So how to write? So you need to add some water. So but when using the Hg2 plus and DIL-H2SO4, right, instead of this triple bond, what will happen? These 2 5 bonds will break. These 2 5 bonds will release by to one carbon to one carbon, these 5 bonds, while these five bonds are removed, one of these carbons will form the double bond oxygen. Double bond oxygen will come up with the double bond oxygen, and the other carbon will come up with the two hydrogens. That is how the H2 molecule will be added to here with the use of this reagent. Right? What happens is these two 5 bonds will remove. One carbon will get the two hydrogens, and the other carbon will get the double bond oxygen instead of the two 5 bonds. Right? So basically, when adding these stuff, always the Markovnikov rule will be followed, unless you are adding the R2O2 HBr. Unless you are adding the R2O2 HBr, the R2O2 medium, always the Markovnikov rule will be followed. The Markovnikov rule means you are supposed to add the hydrogens. You're supposed to add the hydrogens to the carbon bearing greater number of hydrogens. Out of the two carbons of 5 bonds, you have to add the hydrogens to the carbon bearing more number of hydrogens. That is this one. So you're supposed to add the two hydrogens to this one. Two hydrogens to that thing. So then your compound is going to be, nothing happens to these sections. Nothing happens to non-reactive carbons. But with these two carbons, what will happen? This carbon get the double bond oxygen, while this carbon get the two hydrogens. Because this carbon should get the two hydrogens, right? The Markovnikov rule should add the hydrogens to the carbon with greater number of hydrogens out of the two, right? So this carbon will get the double bond oxygen, while the other carbon gets the two hydrogens. Alright? So that is how the H2 molecule is added to these alkynes to come up as an ketone, right now. Okay, let's do this one as well. So you are with the ketone. So addition of this thing, purpose of addition of this reagent, the lithium aluminum hydride, is actually to hydrogenate the polar 5 bonds. To add in the lithium aluminum hydride to hydrogenate the polar 5 bonds. That means this 5 bond, right? This bond will be hydrogenated, giving two hydrogens to these two atoms. Right? So here this adding hydrogens to polar 5 bonds. Adding hydrogens to polar 5 bonds, right? So adding hydrogens to polar 5 bonds. So let's write the compound. You have the CH3, and the two hydrogens will be added like this, OH and H. Clear now? You just need to get rid of this bond and add two hydrogens here and here. This becomes OH, this becomes CH. Then rest of the stuff. These are non-reactive. The alkyl groups are non-reactive, right? Just write this as it was. Right now? Okay, that is how we are supposed to come up with the products of these reactions. Right now? So let's write few more. Let's come up with a few more reactions here from the reactions we have studied so far. Right now. අපි තව reactions ටිකක් කතා කරමු. හැමතිස්සෙම ළමයි මේවා බලන්න මොකද්ද compound එක? ඒ compound එක මේ reagent එකෙන් දාලා අපි මොකද්ද expect කරන්න කියලා. By adding this reagent to the compound, what we are expecting. ඒක ගැන මුලින්ම හිතන්න. Then we can come up with a rule and finalize the product. So always look at the reactive carbons. Reactive carbons means carbons bearing polar bonds or carbons with carbon-carbon 5 bonds. The other carbons are non-reactive. Alkyl groups are non-reactive. Alkyl groups can work with never. Sorry. මෙසේ හිතන්න reactive carbons ලෙන්නේ සින්ට් එක තමයි reaction එකට involve වෙන්නේ. හරිද? reactive සින්ට් එකත් එක තමයි reaction එකට involve වෙන්නේ. මේ සින්ටස් එක නේ. ඒකත් එක්කන අපි හිතන්නේ. reactive සින්ටස් එක තමයි reaction එකට involve වෙන්නේ. reactive carbons. අනිත් carbon වල ගැන worry වෙන්න එපා. reactive සින්ට් එකත් එක්ක හිතන්න මොකද්ද product එක වෙන්න ඕනේ. shape නේද? හරි. තව reactions ටිකක් කරමු. හරි. බීම් වැඩි කරමු නේද? හරි. තව ටිකකින් යන්න. is done. හරි ළමයි මේක තනි කරනවා හිතන කතාවක් තියෙනවා. හොඳේ මේක නිකන් අර කොපි කරන් යන එක විතරක් නෙමෙයි. බෝඩ් එක කොපි කරන එක නෙමෙයි මෙතන තියෙන්නේ. මෙතන පොඩ්ඩක් මොලේ පාවිච්චි කරන්න ඕනේ. වැඩි හිතන්න ඕනේ. හරි. කොහොමද මොන මොලිකියුල්ස් remove කරන්නේ rules වලට set වෙලා වැඩි කරන්න ඕනේ. හරි. තව reactions ටිකක් කරමු. Right, two carbons are there. So first concentrate on these two carbons, right? The reactive carbons, reactive centers, right? HBr. So HBr is used to just the HBr to add the. So our goal is to add some HBr, right? Adding HBr. We are using HBr to add the HBr to alkenes, right? So the hydrogen should be added according to the Markovnikov. According to Markovnikov, when you add in the stuff, hydrogen should be added according to Markovnikov. You are not using the R2O2. If you had used the R2O2, that is anti-Markovnikov. This is just the Markovnikov. Markovnikov says, right, the hydrogen should be added instead of this 5 bond. The hydrogen should be added out of the two carbons. The hydrogen should be added to the carbon with higher number of hydrogens. Here 2 hydrogens are there. Here only just 0, right? So hydrogen should be added here. That is what Markovnikov says. So that to the other atom, Br will be added. So HBr to add no. So your final compound is going to be CH3, C, CH3, and to this carbon it is Br added. For the other carbon, the hydrogen will be added. This carbon-carbon 5 bond, right, will remove. So adding another hydrogen to this carbon means it will come up with 3 hydrogens. Already it has 2, right? The third hydrogen also comes. So it is like this. This is the compound, right? Next stuff. So always concentrate on the what? Concentrate on reactive carbons. No need to think of the other ones, right? So H2SO4 is used to add some water molecule to this stuff, right? So adding H2O. So it's just the addition. So Marconic fluid should be followed. Marconic fluid should be followed. So out of the two carbons, the H should be added to the carbon with higher number of hydrogens. So you have only one hydrogen here. You don't have any hydrogen. So the higher number of hydrogens, carbon with the higher number of hydrogens is this. So just add the hydrogen to the other carbon. You can come up with the OH. The H2O is added. So you are supposed to remove this bond. How the H2O will be added to an alkene, right? So let's write this stuff, right? So this CH3 is there. So some hydrogen is added to this carbon. So already it has one. So the second hydrogen is added. So you can write CH2. That carbon is with two hydrogens now. Then this bond is removed. Only single bond now appears. So with this carbon, some OH comes and two CH3 groups are already there. So OH comes and two CH3 groups are already there. Right now? So that is the product. Right? Let's see this one. So just think of the reactive carbons here. Reactive centers. Then you are adding some HBr. So HBr is 2. Add HBr. So again, this is the normal addition, the Marconic addition. So hydrogen should be added to the carbon with higher number of hydrogens. So out of these two, the carbon participating in the double bond, right? For this double bond, right? Hydrogen should be added to this carbon because it is the one with high number of hydrogens. So the Br will come to here instead of this double bond. Instead of this double bond, the hydrogen comes to here because it is the carbon with high number of hydrogens out of these two. Br comes to here. That will be the ultimate product there. So let's write the stuff. CH3 is there. Then this carbon will come up with two hydrogens now after the addition of the second hydrogen. CH2. The next carbon comes up with a Br and a CH3. This bond is removed. Br and a CH3 for the next carbon. Then the next one, right? It is with a H and a Br. H and a Br. And this bond is removed. And this carbon comes with 3 of hydrogens. Already there were 2 hydrogens. Then the third hydrogen is added, right? Right now. The final shot. Right? So these are the reactive centers. Concentrate on those reactive carbons. Right? So this reagent is used to convert the carbon-carbon triple bond to carbon-carbon double bond. Just to hydrogenate the second 5 bond. Just to hydrogenate the second 5 bond, you are using this thing. Carbon-carbon triple bond converts to carbon-carbon double bond. That is the usage of this reagent. Right? No need to write these things, right? That is how you think, right? It's how you think. This is not the answer, right? No need to write this thing at the answer script, right? You no need to show this working in your answer sheet, right? You are supposed to just come up with the answer, right? This is just the answer. That is what you need to come up with, right? I'm just explaining you how to think of these things, right? So this reagent is added to convert the carbon-carbon triple bond to carbon-carbon double bond. That should come to your mind when you see this reagent. So you have a carbon-carbon triple bond. So this will be converted to a double bond. But you have a carbon-carbon double bond here. So there is no further reaction with that thing. There is no further reaction with the double bond, right? This will end up with the double bond. Double bonds will not going to further react to come up with a single bond, right? So that won't happen. So only the triple bonds will be converted to double bonds with this reagent. If you have added only the H2PD, then both the bonds will hydrogenate till you come up with the alkane form. There's only single bonds will ultimately can be seen if you have just added the H2 and PD only. But here the H2PD with the barium sulfate quinolene. So with this reagent, the hydrogenation will stop at the double bond stage, right? So the product will be then only this area will react, participate in reaction, not this area, right? So it is going to be CH3. The triple bond converts to double bond, right? Right now, 2 hydrogens will be added now. Instead of this triple bond, 2 hydrogens will be added now. So instead of 1 5 bond, right? Then you come up with another CH2 and CH. Nothing happens to the double bond, right? And CH2. Nothing happens to the double bond, right? So that is how we are supposed to come up with the final compound, right? Let's do another 2 conversions. So just adding organic reagent to convert our starting compound to a new compound. That is simply the conversion is. These are the existing stuff in our laboratory. By adding these reagent, we have came up with a new compound, right? That is what simply the conversions means, right? Or new organic compound synthesis means. So we have synthesized a new compound, right? No? Okay. Let's do another 2 questions. ඔයාලා ලියන ආන්සර් කියලා මේ හැමතිස්සෙම බලන්න මේ කාබන්ස් ද බොන්ස් 4ට වඩා තියෙන්න බෑ හොඳේ. ලියන ආන්සර්ස් සමහර ළමයිට වරදිලා කාබන්ස් ද බොන්ස් 4ට වඩා වැඩියෙන් ලියන. කාබන්ස් වලට බොන්ස් 4ට වඩා අඩුවෙන් ලියන. අන්න එහෙම වෙන්න බෑ හොඳේ. හයිඩ්‍රජන් කෙනෙක් කියන්නේ බොන්ඩ් එකක් කාබන් එක තියෙන. එතකොට මේ එකක් ලිව්වට පස්සේ ආන්සර් පොඩ්ඩක් බලන්න. Whether you are exceeding the 4 bond situation with the carbons or whether you are lacking of 4 bonds with your carbons. Just check that, right? After finalizing your answers, right? පොඩි වැරදි වෙන්න පුළුවන්. සමහරකට හයිඩ්‍රජන් ල අමතක වෙනවා දාන්න. සමහරකට හයිඩ්‍රජන් ල වැඩිපුර ලිය වෙනවා. යා ඒ කේස් එක බොන්ඩ්ස් 4කට වඩා වැඩියෙන් හෝ අඩුවෙන් ලියන්න පුළුවන්. එහෙම වෙන්න බෑ. කාබන්ස් වල exactly 4 bonds තියෙන්න ඕනේ. bonds count කරන විදිහ තමයි කිව්වේ. සාමාන්‍යයෙන් හයිඩ්‍රජන් කෙනෙක් කියලා කියන්නේ කාබන් එක තියෙන එක බොන්ඩ් එකක්. right? හරි. බලමුද වැඩි. Right, let's do the stuff. So this is kind of a ketone. This is your reactive carbon. So you are adding this stuff to convert this carbon-carbon 5 bond to two hydrogens. To two hydrogens. That is the use of this reagent. Hydrogenating or adding hydrogens to, right, carbon sorry, polar bonds, no, polar 5 bonds. That is the usage of the reagent, right? So so two hydrogens will connect here, one here and the one here instead of this 5 bond, right? So the product will be CH3, the OH and some hydrogen, right? To here one hydrogen, to here one hydrogen, right? Then these are as normal, right? Nothing happens to those. Those are not reactive here. හරි නේද වැඩි? හරි. දැන් මේ මොකද වෙලා තියෙන්නේ? මෙතනට යන්න මොකද වෙලා තියෙන්නේ? ඔයාලට පේන්නේ වැඩි? මොකද වෙලා තියෙන්නේ වැඩි? හරි. මෙයා තමයි රියැක්ටිව් කාබන්. උට මොකද වෙලා තියෙන්නේ? වෙලා තියෙන්නේ බලන්න. වෙලා තියෙන වැදගත් දේ. වෙලා තියෙන්නේ මොකද්ද? ඒතකොට රීජන්ට් එක හොයාගන්න පුළුවන්. නැත්නම් රීජන්ට් එක හොයාගන්න බෑනේ මොකද්ද වෙලා තියෙන්නේ කියලා නැතුව. වෙලා තියෙන්නේ මෙතන OH කෙනෙක් අයින් වෙලා මේ OH අයින් වෙලා නෑනේ. ඊට පස්සේ මේ එහා පැත්තේ කාබන් එකෙන් හයිඩ්‍රජන් කෙනෙක් අයින් වෙලානේ. මූත් අයින් වෙලානේ. Just see the difference. What have happened? Going from reactant to product. This is the reaction arrow. So at this side, this is the reactant, and this side, this is the product. So these two have removed and formed this new bond. So getting rid of a H2O molecule to form the 5 bond. That is what has happened. So for that, we have to come up with what? What is the reagent? Concentrate H2SO4 with the heat. Consider H2SO with the heat. Right? Not only consider H2SO with the heat, right? You need hot concentrated H2SO4 to do the dehydrations, right? Remove H2O molecules. Right. The H2O molecule will be gathered by this one. This is lack of H2O molecules. Concentrated, no? Lack of H2O molecules. So this H2O molecule will be removed towards the concentrated H2SO4. Right. What about this? So you are now with a alkene. That is how you are supposed to think, right? So these are the reactive carbons. So what has happened? What should happen? So basically you have 5 bond here. This reagent is to add some HBr. This reagent is to add some HBr, but anti-Markovnikov of manner. Adding HBr, anti-Markovnikov. That is what should come to your mind when you see this reagent. This is what should come to your mind when you see this reagent, right? Adding HBr in the anti-Markovnikov manner. So that means the hydrogen should be added not to the carbon with higher number of hydrogens, but to the carbon with lower number of hydrogens. The Markovnikov addition means hydrogen should be added to the carbon with higher number of hydrogens. But the anti-Markovnikov means hydrogen should be added to the carbon with lower number of hydrogens. The opposite, right? So out of these two carbons, this is the carbon with lower number of hydrogens. So there you have to add the hydrogen. To the other carbon, you have to add the Br. Adding the hydrogen to the carbon with lower number of hydrogens. That is what anti-Markovnikov means. Anti-Markovnikov. So this will be removed, right? So the product will be, you have a CH3 with this carbon. Now H and a Br is there. CH, the Br appears. Then the other carbon, that carbon contains a hydrogen and a 2 CH3s, right? That carbon contains a hydrogen and a 2 CH3s, like this. Right now? That is the idea, right? Right, note number 2. So I had given some name to this one, right? It is said as 7 valence electrons. Right? The name is actually with BrOH NH2. Just a name, right? I just given a name to this reaction sequence. Right? Okay. The idea is this. Right. So, this is the idea. Let's say you have a right. So I'll okay. First of all, I'll tell you a story. That is better to grab this idea, right? With the sequence, right? So you can see some reactions are appearing like this. Right, some Br. Right, then you clearly see diagram like this. So there's a diagram, right? Let's discuss about these conversions. So to get some idea, right? So first complete this one. So we can put some NaOH to here. This thing you can come up with some HBr, right? Or PBr3. To do this change, you can add the NH3. To do this one, you can add the NaNO to it here, right? I'll discuss first this section, what this means, right? So I'll tell you a story. Right? So it's like this. See? So this is the story, right? පොඩි කතාවක් කියන්න. හරි? මේ කතාවත් එක්ක ඔයාලා මේකේ idea එක හොඳටම ගන්න පුළුවන්. right? හිතන්න දැන් මේ යාළුවෝ දෙන්නෙක් ඉන්නවා. හරි? යාළුවෝ දෙන්නෙක් ඉන්නවා. right? See? Two friends are there. හරි? යාළුවෝ දෙන්නෙක් ඉන්නවා. හරි? මේ විදිහට යාළුවෝ දෙන්නෙක්. හරි? කවුද මේ උදාහරණයක් ගමුනේ අපි යාළුවෝ දෙන්නම. හරි? අනුර ඉන්න අනුර. අනුරයි නාමලි. හරි? යාළුවෝ දෙන්නෝ දැන් එවලක් නැහැ. හරි? නාමලි අනුරයි ඉන්නවා. හරි? right. So two friends. right? දෙන්න ඉන්නවා. නාමල් and අනුර. හරි දෙන්න ඉන්නවා. හරිද? එතකොට දැන් මේ මේන් වැඩක් වෙන. කියන්නේ දැන් මේගොල්ලෝ දැන් මේ කාලේ තමයි මේ කාලේ මේගොල්ලෝ කෙමිස්ට්‍රි ඉගෙන ගන්න කාලේ. හරි? කෙමිස්ට්‍රි මේගොල්ලෝ ඕගනික් කෙමිස්ට්‍රි කරන කාලේ. හරි? ක්ලාස් එකේ ඕගනික් කෙමිස්ට්‍රි ඉගෙන ගන්න කාලේ තමයි දැන් මේ ඉන්නේ. දෙන්න. හරිද? මේ ඉනෝගනික් කෙමිස්ට්‍රි ඉවර කරලා ඉන්නේ. ඉනෝගනික් කෙමිස්ට්‍රි වැඩ ඉවර කරලා හොඳට වැඩ ටික කරගෙන දැන් ඕගනික් කෙමිස්ට්‍රි ඉගෙන ගන්න කාලේ තමයි මේ ඉන්නේ දෙන්න. හරිද? දැන් ඉනෝගනික් කෙමිස්ට්‍රි ඉගෙන ගන්න කාලේ ළමයි ඒගොල්ලෝ මේ ඉනෝගනික් කම්පවුන්ඩ්ස් වලට ආස වෙලා ඉනෝගනික් රියැක්ෂන්ස් වලට ආස වෙලා රයිට් ක්ලාස් ගිහිල්ලා ආස වෙලා රයිට් ඒගොල්ලෝ දැන් ගෙදර ලැබ් එකක් හදාගෙන තමයි ඉන්නේ. දැන් ගෙදර ලැබ් එකක් තියෙනවා. රයිට්. දෙන්නටම තියෙන ඉනෝගනික් ලැබ් එකක්. හරි. යාළුවෝ දෙන්නෙක් නේ. දෙන්නටම ඉනෝගනික් ලැබ් දෙකක් තියෙනවා රයිට්. ලැබ් දෙකක් තියෙනවා. දැන් ගෙදර ලැබ් එකක් හදන් තමයි ඉන්නේ ඕනේ. ලැබ් එකක් කියලා ගහන ලොකුට දැන් යට වැඩි යනවා මේ නාමල් හවුස් රයිට්. නාමල් ලැබ් එක තියෙනවා. ඊට පස්සේ අනුර ලැබ් එක තියෙනවා. පොඩියට ඉතින් ළමයි ඉතින් දන්නවනේ. කෙමිකල්ස් ටිකක් අරන් ඉතින් දැන් ලැබ් එකක් හදාගෙන ඉන්නවා. හරිද? දැන් ඉතින් මේ ඕගනික් කරන්න පටන් ගත්තා. ඕගනික් කරන්න පටන් ගත්ත පස්සේ මේගොල්ලන්ට මේ ඕගනික් රියජන්ට්ස් උත් ලැබ් එකට ගේන්න ඕනේ ඒගොල්ලෝ. ගෙදර හදාගත්ත පුංචි ලැබ් එකට ඕගනික් දේවලුත් ගේන්න ඕන කමක් තියෙනවා දැන්. හරිද? එතකොට මුලින්ම නාමල්. නාමල් මොකද කරන්නේ? නාමල්නේ සාමාන්‍යම වීඩියෝ වලට ඉස්සරහ මූලිකත්වය ගන්න. හරි? නාමල් කරන වැඩේ නාමල් යනවා කොටුවට. කොටුව දිනන කොටුවට යනවා. කොටුවට ගිහිල්ලා මේ කඩෙන් ගිහිල්ලා ඉතින් කොටුවේ පීරලා බලලා හැමතැනම හොයලා නාමල් කොහොම හරි එක කම්පවුන්ඩ් එකක් හොයාගෙන එනවා. කොටුවේ දිනනවා නේද? ෂොප් එකේ දිනනවා හරි. කෙමිකල් ෂොප් එකේ දින ඉතින් හරි. කොටුවේ කෙමිකල් ෂොප් එකට ගිහිල්ලා දිනවලා දන්නවනේ. හරි. එහෙම ගිහිල්ලා මේ එයා හොයලා හැමතැනම හොයලා ගිහිල්ලා හොයාගෙන එයා එනවා. හිතන්න එයා හොයාගෙන ආව මෙන්න මේ කෙමිකල් එක. දැන් එයා ළඟ හොයාගෙන ආව මෙන්න මේ කෙමිකල් එක. ඕගනික් කම්පවුන්ඩ් CH3 CH2 BR CH2 CH2 BR කියන කම්පවුන්ඩ් එක යා කොටුවට ගිහිල්ලා මාර ගේමක් දීලා දවසක් පුරා නේද? ඇවිදලා වෙල්ලා හොයාගෙන එනවා. හරි. හොයාගෙන එලා දැන් ඒක යාගේ ලැබ් එකේ දිනනවා. හරි. දැන් යාගේ ලැබ් එකේ දිනනවා ඒක. ලැබ් එකේ හරි දැන් දිනනවා ඒක. හරි. රයිට්. මෙච්චර තමයි හම්බ වෙන ළමයි. කොච්චර හෙව්වත් කොටුවේ බෝරි වීරලා හැමතැනම හොයනවා. හැමතැනම හෙව්වත් යාට හම්බ වෙන්නේ මෙයා විතරයි. අර මම සාමාන්‍යයෙන් මම අර කිව්වනේ ලෝකේ තියෙන කම්පවුන්ඩ්ස් එක්ක බලද්දී ඕගනික්. හරිද? ලැබ් එකක තියාගන්න පුළුවන් ප්‍රමාණය හරි සීමිතයි ළමයි. හරි අපි දැන් ඕගනික් ලෙසන් එක පටන් ගන්නදී කිව්වා නේද? ඕගනික් කතාව පටන් ගන්නදී කිව්වා. රයිට්. සාමාන්‍ය බයෝ දැන ඕගනික් නේ. හැමදේම ඕගනික් නේ. හරි. කන බොන දේවල් ඉතින්ද ලියන දේවල් පොතපත ඉඳ ගන්න තැන වාහනේ රබර් මේ වාහනේ ටයර්ස්ද තාරද හැමදේම ඕගනික් ඉතින්. ලෝකේ තියෙන ඕගනික් දේවල් එක්ක බලද්දී අපිට ලැබ් එකක තියාගන්න පුළුවන් ඕගනික් ප්‍රමාණය හරි පොඩ්ඩයිනේ. ඕගනික් වගේ නෙමෙයිනේ. ඉතින් කොහොම හරි මෙයා රයිට් කොටුවේ පීරලා බලුවොත් එයාට හම්බ වෙන්නේ ඉතින් ඔය ඕගනික් එක විතරයි. මේවා සාමාන්‍ය ගිනි ගන්න අසුළු ප්‍රශ්නක් තියෙනවනේ. අවైలබල් නැහැ. ඉතින් ඕගනික් කියව තරම් ලීසින් ස්ටෝර් කරන්න බෑ. ඉතින් පොඩ්ඩක් පරිස්සමෙන් වැඩේ කරන්න ඕනේ. ඉතින් කොහොම හරි කොටුව පුරාම පීරලා එයාට හම්බුනේ මෙයා විතරයි ඕගනික් එක. හරි. එයා ඒක යාගේ ලැබ් එකට ඉතුරු කරනවා. දැන් එයා ඕගනිකුත් ඉගෙන ගන්න කාලේ ඕගනික් ඒකත් දැන් එයාට තියෙනවා. හරි. ඉතින් ඔහොම ඉන්නකොට ළමයි නාමල් ඉන්නකොට දවසක් අනුර එනවා නාමල්ට පොඩි විසිට් එකක් දාන්නේ. අනුර පොඩ්ඩක් එනවා. නාමල්ලා ගෙදරට පොඩ්ඩක්නේ බල්ල යන්නේ යාළුවා හම්බ වෙලා යන්න. හරි. යාළුවා හම්බ වෙලා යන්න ඔහොම එනකොට අනුර. හරි. අනුර දකිනවා දැන් මෙයාගේ ලැබ් එකේ තියෙන මොකද්ද? CH3 CH2 BR. there is a organic reagent. organic reagent නැති ලැබ් එකේ. හරි. organic reagent ලැබ් එකේ තියෙනවා. ඉතින් අනුරට දැන් කැමතියි මොකද දැන් මේ කාලේ ඕගනික් ඉගෙන ගන්න ඉන්නේ පන්තියේ නේද? හරි ඒක නිසා අනුර අහනවා නාමල්ගේ මචං කොහෙන්ද ඔය ඕගනික් එක හොයාගත්තේ? ඉතින් අනුර ඊට පස්සේ නාමල් කියනවා මම කොටුව පුරාම පීරලා වටේම ගිහිල්ලා බොහොම අමාරුවෙන් හොයාගත්ත එක මේක උච්චරයි. ඕක තමයි ඉතින් කොටුවෙන් හම්බුනේ කියලා. ඕක විතරමයි කොටුවේ තියෙන්නේ කියලා. කියන්නේ මේ જાති ඒව විතරයි තියෙන්නේ. ඔයාට ඕන තරම් CH3 CH2 BR නම් කොටුවෙන් ගන්න පුළුවන්. හැබැයි වෙන කම්පවුන්ඩ්ස් නම් කොටුවේ නැහැ. only this is available from that shop that chemical shop I bought that. නාමල් කියනවා. right? ඒතර එහෙනම් අනුර කියනවා හොඳයි thank you මචං කියපුවේ කියලා. අනුර මොකද කියන්නේ? එහෙනම් මාත් ගිහිල්ලා එකක් ගන්න ඕනේ කියලා. ඊට පස්සේ දවස් උදේම අනුරත් යනවා කෙමිකල් ෂොප් එකට. කෙමිකල් ෂොප් එකට අනුර ගිහිල්ලා අනුරත් ඒ ඕගනික් රීජන්ට් එක අරන් එනවා. හරි ඕගනික් එක්කෙනාව එයාත් අරන් එනවා. right? now Anur is also with CH3 CH2 BR with his lab. දැන් රටත් එක දිනන. හරි දැන් ළමයි වැඩේ කියන්නේ මෙහෙම දැන් අර මේගොල්ලෝ ළඟ දෙන්න ළඟම හොඳට ඉනෝගනික් කියව තියෙන හොඳේ. ඔක්කොම ඉනෝගනික් දේවල් ටික තියෙනවා නේ. ඉනෝගනික් දේවල් ටික දෙන්න ළඟම තියෙනවා නේ. මොකද ඉනෝගනික් ලැබ් එකවල කලින් හදලා තිබ්බේ. ඒගොල්ලෝ පාඩම් කරන කාලේ මේ ඉනෝගනික් ටික ඉවර කරන කාලේ ඒ ටික ඉනෝගනික් වැඩ ටික කරන් තිබ්බේ. ඒ ලැබ් එකේ අදාළ H2SO4ද HCl ද නයිට්‍රික්ද ඒ ඔක්කොම තියෙන. ඒවා සාමාන්‍ය උන්තරේ හොයාගන්න පුළුවන් ඉනෝගනික් දේවල්. හරි එතකොට ඒ ටික තියෙනවා. ඕගනික් එක පොඩ්ඩක් හොයාගන්න අමාරුයි. මෙයාත් කොටු මෙතනට කෙමිකල් ෂොප් එකේ මෙයා අරන් ආවා. ඉතින් නාමල් කිව්වනේ වෙන කොහෙවත් මේ හැමතැනම බැලුවා හම්බුන්නේ නැහැ කියලා. ඉතින් අන්න ඉතින් වෙන තැන් වලට බලන්න යන්නේ නැහැ. එයා කෙමිකල් ෂොප් එකෙන් අරන් එනවා. හරි වෙන තැන් හොයන්න යන්නේ නැහැ. හරි. දැන් ඔහොම ගිහිල්ලා දැන් අන්න එහෙම අරන් ආවොද? ඊට පස්සේ දවසේ දැන් ඔහොම ගියාට පස්සේ දැන් ඊට පස්සේ දවස් නාමල් දැන් සතියක් විතර ගිහිල්ලා නාමල් එනවා අනුර ගෙදරට විසිට් එකක් දාන්න. නාමල් එනවා අනුර ගෙදරට විසිට් එකක් දාන්න. හරි. අනුර බලන්න එනවා. එතකොට අනුරගේ ලැබ් එක තියෙනවා. හැබැයි වැඩේ කියන්නේ අනුරගේ ලැබ් එකේ ඒ වෙලාවේ මෙයා විතරක් නෙමෙයි. මෙන්න තව සෙට් එකක්ම තියෙනවා. හරි. අනුරගේ ලැබ් එකේ මේක විතරක් නෙමෙයි. හරි සෙට් එකක්ම තියෙනවා. BR විතරක් නෙමෙයි ඕව චුත් තියෙනවා. ඇල්කොහොල් එකක් තියෙනවා. හරි. ඒ විතරකුත් නෙමෙයි අනුරගේ ලැබ් එකේ හරිද? මේකක් තියෙන. OH දෙකුත් නෙමෙයි NH2 තියෙන. හරි? දැන් උන්ගේ ලැබ් එකේ මේ සෙට් එකම තියෙනවා. නාමල් ලිස්ට් එකක් දාන්න ඕන මාමල් ලගිනවා. මෙන්න මෙයාගේ ලැබ් එකේ මෙන්න ඔක්කොම කට්ටිය ඉන්න. හරි? එතකොට මේ දැන් අනුර අහනවා නාමල් අහනවා අනුරගෙන් මේ ඊවන් කොහෙන්ද උඹට මේ ටික හම්බුනේ? කොහෙන්ද ඔයා මේ ටික හොයාගත්තේ? හරි මම ෆොටෝ පුරාම වැළුවනේ මේ මට හම්බුනේ CH3 CH2Br විතරයිනේ. දැන් අලුතෙන් ඔයා කඩේට ගිය වෙලාවේ මේ ටිකක් තිබ්බද ෂොප් එකේ? අනුර කියනවා නෑ එහෙම තිබ්බේ නෑ. මං ගිය වෙලාවේ මට හම්බුනේ CH3 CH2Br විතරයි. අනුර කියනවා. නාමල්ලාම එහෙමද මේ එතකොට කොහොමද මේක හම්බුනේ මේ බොරුනේ කියන්නේ ඔය ෂොප් එකෙන් ගත්තනවා නිකන් බොරු කියන්න එපා නිකන් නරක වැඩ කරන්න එපා නේද මං ඔයාලට කිව්වනේ කොහෙද තිබ්බි කියලා ඔයා මොන ෂොප් එකෙන්ද ඔක හොයාගත්තේ එහෙම අහනවා ඉතින් අරයා කියනවා නෑ නෑ එහෙම නෑ මාත් ගියේ කෙමිකල් ෂොප් එකට විතරයි මට හම්බුනේත් මේක විතරයි ඒකෙත් වෙන මොකුත් තාම නෑ කිව්වා CH3 CH2Br විතරයි තිබ්බේ දැන් අනුර කොච්චර කියනවා ඉතින් අර නාමගේ නෑ නෑ බොරු කියන්නේ ඉතින් ඔයා ඉතින් හැමදාම බොරු කියන එක නේ කොහොම කියලා ඉතින් කියනවා ඉතින් හරි ඉන්නකො මං ගිහලා හොයලා බලන්න කියලා ඔන්න නාමල් යනවා ආයෙසරයක් කෙමිකල් ෂොප් එකට ගිහිල්ලා බලනවා ඇහුවට පස්සේ කෙමිකල් ෂොප් එකේ මිනිස්සු කියනවා නෑ අපි ළඟ තියෙන CH3 CH2Br විතරමයි වෙන මොකුත් නෑ හරි කොච්චර නාමල් කිව්වොත් ටිකක් පොඩ්ඩක් තග දාලත් අහනවා දන්නවනේ මං අරයාගේ අරයා මෙයා මට ඕනේ කියලා කිව්වා ඒත් තග දැම්මත් අරු බය නැහැ ඉතින් මිනිස්සු මම ළඟ නැති දෙයක් කොහොමද දෙන්නේ කියලා කියනවා නෑ CH3 CH2Br විතරයි තියෙන්නේ මේක කවුරුත් නෑ ඉතින් ඇත්ත නිය හරි ඉතින් නාමල් ඊට සමග කරන්නේ හතර වටේම හොයනවා ආයෙත් සැරයක් හතර වටේම පීරලා හොයනවා එක ෂොප් එකකවත් ඒරෙන්න වෙන දෙයක් නෑ හරිද ඉතින් ආයෙත් ඉතින් නාමල් එහෙම එනවා ඉතින් ගෙදරට මේ මොකක් හරි මේ කීයක කෝස් අවුලක් තියෙනවා මොකද්ද කියන්නේ මේ වැඩක් නැහැ උන්ට මහා පාප මිත්‍රයෝ ගාගෙන නේ මාළුකෝට නේ හිටියට මේ කිසි වැඩක් නැහැ අපි උලට උදව් කරලා ඒගොල්ලෝ අපිට උදව් කරන්නේ නැහැ උන් ගියාගෙන ඉතින් නාමල් එනවා විතර හරි ඇත්තටම මොකක්ද උනේ ඇත්තටම වැඩේ මොකක්ද උනේ අනුර බොරු කිව්වද රයිට් නැත්තම් ෂොප් වල වලින් තිබ්බද මොකද උනේ ෂොප් වල නැහැ නම ඇත්තටම ෂොප් එකේ නැහැ කොච්චර ඇත්තටම උනේ මේකයි ළමයි දැන් අනුර මේ කාලේ හරි අනුර මේ කාලේ හරි අපේ රුක්ෂාන්සගේ පන්ති දෙනවා හරි පන්ති දෙන මිනිහා අනුර කියන්නේ දන්නවනේ ආ කෙලින්ම බොක්කෙම ඉගෙන ගන්න මිනිස්සයා නිකන් ඔහේ ඔහේ බෝඩ් එකේ දානක ලියන්නේ එහෙම ඩයල් එකක් නෙමෙයි නෑ බොක්කෙම ඉගෙන ගන්නවා කියන්නේ ඉගෙන ගන්න මිනිස්සයා දවසින් දවස අප්ඩේට් වෙන මිනිස්සෙක් නාමල් වගේ නෙමෙයි නාමල් එල් ඔක්කොම ටික ගොඩ ගහගෙන අන්තිමට ගිහිල්ලා අර නිකන් අන්තිම මොහොතේ තමයි වැඩේ කරගෙන මොකක් හරි ගොඩ දාගන්න මොකක් හරි අමුතු ගේමක් ගහලා ගොඩ දාගන්න කෙනෙක් නාමල් කියන්නේ කවදාවත් වැඩි පිළිවෙලට කරගෙන නෙමෙයිනේ අනුර එහෙම නෑ පිළිවෙලට වැඩි දවසින් දවස අප්ඩේට් වෙලා යන මිනිස්සයා. ඉතින් මිනිස්සයා මේ කාලේ රුක්ෂාන්සගේ පන්තියේ ඕගනික් ඉගෙන ගන්න කාලේ. එතකොට ඒ කාලේ ඉගෙනුවා මොකද්ද? අපිට මෙහෙම මේ CH2 CH2Br එකක් තියෙනවා නම් අපිට ඒක කන්වර්ට් කරන්න පුළුවන් OH එකකට with the addition of NaOH. ඉතින් අනුරගේ ලැබ් එකේ මේව ටික තියෙනවනේ. නෝගනික් ලැබ් එකේ කලින් තිබ්බනේ. ඒක නිසා එයා මොකද කරන්නේ? අනුර කරන්නේ සරලම දේ මොකද්ද? එයා මෙන්න මේකෙන් පොඩ්ඩක් බීකර එකට අරගෙන මේකෙන් පොඩ්ඩක් බීකර එකකට අරගෙන එයා ඒකට ඇඩ් කරනවා මොනවද? එයා ඒකට ඇඩ් කරනවා NaOH. CH3 CH2Br ගෙන් පොඩ්ඩක් බීකර එකට අරගෙන එයා ඇඩ් කරනවා NaOH. එතකොට මොකද වෙන්නේ? එතකොට ඔයාගේ මේ බීකර එකේ තිබ්බ CH3 CH2Br ටික කන්වර්ට් වෙනවා කාටද? CH3 CH2OH වලට. දැන් බීකරේ තිබ්බනේ CH3 CH2Br ඒ ටික කන්වර්ට් වෙනවා කෙලින්ම CH3 CH2OH වලට. Then he will add that thing to a reagent bottle and then he had labeled that thing as the CH3 CH2OH. හරි මෙහෙම දාලා CH3 CH2OH ටික එයා බෝතලයකට ඇඩ් කරලා reagent bottle එකට ඇඩ් කරලා වෙනම label එකක් ගන්නවා. That is how he had created the CH3 CH2OH out of CH3 CH2Br. Right? Then, after that, he had managed to form the CH3 CH2 NH2 as well. How come? He had just added some CH3, some NH3, which is a inorganic reagent. He had just added some NH3 to the CH3 CH2Br he had, and then it will produce the CH3 CH2 NH2. See, by adding NH3, you can come up with the amine with the same R group. Amine with the same R group. Here the R group won't change. Amine with the same R group. So by the addition of NH3, the CH3CH2Br will convert to CH3CH2NH2. So then he will add that thing to a reagent bottle and just label that. That is how the CH3CH2NH2 comes to his laboratory. Right? So that is how the our Anura was able to come up with these three reagents. Right? Where Namal was unable to. Right? හරි ඉතින් ඔහොම තමයි අනුර වැඩි කරේ. හරි? ඉතින් ওই කතාව තමයි මේ මම ඔයාලට කියපු කතාව. ඉතින් මේකේ තේරුම් ගන්න කාරණේ මොකද්ද? ළමයි, if you just have one of these guys, you can create the other two. Just having one of these three guys, right, will give you access to create the other two. ඒ කියන්නේ ළමයි එක්කෙනෙක් ඉන්නවා නම් ඔයාට ඇත්තටම ඒ R group එකම තියෙන අනිත් දෙන්නව හදා ගන්න පුළුවන්. Because the inorganic reagents are available with our laboratory, right? So all the inorganic things are available now. So having one is enough to come up with the other two. ඒ කියන්නේ ඔයාලඟ right alkyl halide එකක් තියෙනවා නම් ඒ R group එකම තියෙන alcohol එක ඔයාලට හදා ගන්න පුළුවන් by just adding this reagent. And you can create the amine with the same R group by adding NH3. If you had ROH, then the alcohol, then you can create the alkyl halide with the same R group by just adding PBr3 or HBr to the alcohol. If you had the alcohol, you can create the amine with the same R group. You can create the amine with the same R group by just converting that thing first to the alkyl halide, then to the amine by adding the respective reagents. If you had RNH2 in your laboratory, then you can create the ROH by just adding NaNO2HCl, and you can create the RBr by adding the NaNO2HCl and then converting it to the RBr by adding HBr and PBr3 or PBr3. See, just having one of these will give you the all three. එක්කෙනෙක් ඉන්නවනම් ළමයි තුන් දෙනාම ඉන්නවා කියලා ඔයාට දැනෙන්න ඕනේ. හරි එක්කෙනෙක්ව starting compound විදිහට ඔයාලා laboratory එකේ දීලා තියෙනවා නම් ඔයාට දැනෙන්න ඕනේ අනිත් දෙන්නත් මට හදා ගන්න පුළුවන් කියලා. මේ තුන් දෙනාගේ එක්කෙනෙක් හරි ඉන්නවා කියලා කියන්නේ අනිත් දෙන්න හදා ගන්න පුළුවන්. That is what it says with the topic. Seven valence electrons, Br, OH and NH2. The Br, OH and NH2 all are having 7 valence electrons. Br is group 17, oxygen 16 and hydrogen is the 7 electrons. NH2 again 7 valence electrons. So those groups can be replaced easily by just simply adding some inorganic reagents. That is why the topic says like this, right? No? So that is the story of this thing, right? එක්කෙනෙක් ඉන්නවා නම් අනිත් දෙන්නව හදා ගන්න පුළුවන්. ඒගොල්ලගෙන් කරන්න පුළුවන් සින්තසිස් පාත්වේස් වලට ඔයාට යන්න පුළුවන් කියන එක මෙතනින් ඔලුවට ගන්න ඕනේ. මෙයා ඉන්නවා කියලා කියන්නේ මේ දෙන්නත් ඉන්නවා වගේ දැනෙන්න ඕනේ එකට. ඇල්කොහොල් එක ඉන්නවා කියන්නේ ඇල්කයිල් හැලයිඩ් එකයි ඒ R group එකේ තියෙන ඇමීන් එකයි ඉන්නවා කියලා ඔයාට දැනෙන්න ඕනේ. ඒක තමයි කතාව. Right නේ? හරි. There is a relationship between these three guys. Right? Okay, very important, right? ඒ තුන් දෙනාගේ කතාව. එක්කෙනෙක් ඉන්නවා කියලා කියන්නේ අනිත් දෙන්නත් ඉන්නවා කියලා දැනෙන්න ඕනේ. Right? So some other reactions are also indicated here. Some very important two reactions. With this one, you can create the cyanide. You can convert the Br to cyanide, right? By just adding, right, KCN. You can complete this stuff as well, right? So you can convert this one to a reagent called Grignard reagent. The other Br will be converted to the MgBr. For that, what you need to add is just some magnesium. To give some magnesium here, just some magnesium in dry ether medium. Right? So complete those two reactions as well to complete the picture, right? Okay. That is the story about the three guys. Okay. Let's move to few more reactions. තවත් මේ වගේ connection එකක් ගැන තරන්නේ දෙයියන්නේ. Right? So the idea is this. So these are alcohols. These are referred to as alcohols, right? Alcohols. Right? Okay. So alcohols are of three types. Now alcohols are of three types. There are three kinds of alcohols. Three types of alcohols. What are those? So primary alcohols, secondary alcohols, and the tertiary alcohols. See? This R group with this. So if the alcoholic carbon contains only one R group, if this alcoholic carbon, the reactive carbon, if it's only one R group, it's only with one R group, those are referred to as primary alcohol. Primary alcohol. Right? Like that, if your alcoholic carbon, the OH containing carbon, is with two R groups, like this, with two R groups, two alkyl groups, then these are referred to as secondary alcohols. This is primary alcohol, one R group. This is kind of secondary alcohol, alcohol with two R groups. So if your OH containing carbon is with three R groups, I'll just put it as R1, R2, R3. The R groups can vary, right? No need to have the same R group there. So same alkyl group. Then those are referred to as tertiary alcohols, right? Those are tertiary alcohols. There are three kinds of alcohols. Right? These alcohols are of three kinds. We'll discuss the relationship between the alcohols and the stuff. Right? So the thing is this. So you can convert, or you can oxidize these carbon-hydrogen bonds. So basically these carbons can be oxidized gradually by removing these carbon-hydrogen bonds and connecting some carbon-oxygen bonds to these carbons. Right? The carbons in your primary and the secondary alcohols can be oxidized by removing their carbon-hydrogen bonds. Removing carbon-hydrogen bonds means oxidation. No? By removing their carbon-hydrogen bonds, and instead of that, adding some carbon-oxygen bonds. So alcohols in primary and secondary alcohols can be oxidized like that, but not in tertiary alcohols, because tertiary alcohols you don't have carbon-hydrogen bonds to oxidize. So no reaction there. So you can't get oxidized. You can't oxidize the tertiary alcohols, right? Other than the tertiary, the primary and secondary alcohols can be oxidized like this, and simply oxidize by removing the carbon-hydrogen bonds, right? See, you just remove this carbon-hydrogen bond and added some carbon-oxygen bond, right? You had removed the carbon-hydrogen bond and added this new carbon-oxygen bond. This kind of oxidation, and this compound is referred to as an aldehyde. As an aldehyde. So you can do this, and you can oxidize further. Another one carbon hydrogen bond is there, so you can oxidize that thing as well. You can oxidize that thing as well. We are in the same R group. You can oxidize the second carbon oxygen bond as well, like this. See, this carbon is oxidized, right? Instead of this carbon hydrogen bond, now you have carbon oxygen bond to convert the aldehyde to a carboxylic acid. That oxidation can be done, right? You can oxidize like this, right? You can oxidize the primary alcohol to aldehyde as well as you can oxidize the primary alcohol directly to the carboxylic acid as well by oxidizing both the carbon hydrogen bonds. You can do so, right? Alcohol එක aldehyde එකට convert කරනවා වගේම එක සැරේම alcohol එක carboxylic acid එකට convert කරන reagents ලා available water. Reagents water available. Right? Let's discuss about that thing. Right? And then not only the oxidations, you can reduce these carboxylics by getting rid of carbon oxygen bonds and forming some carbon hydrogen bonds. So you can reduce the carboxylics like this. You can do this thing as well. මෙයා oxidize කරනවා වගේ මෙයා reduce කරන්නත් පුළුවන්. Here what has happened? This guy has released its carbon oxygen bonds, 2 of the carbon oxygen bonds, swap it 2 of carbon hydrogen bonds. It's a reduction, adding hydrogens. So these processes can be done, right? You can reduce the aldehyde as well to the alcohol. Okay, first you can reduce the aldehyde as well to the alcohol. The carboxylic and the aldehyde both can be reduced to the alcohol, primary alcohol, with the same R group, and the alcohols as well as aldehydes can convert to the carboxylic with the same R group. So you can clearly see some symmetric nature. You can clearly see some symmetric nature with this picture, right? If this arrow is not there, you can clearly see some symmetric nature with this picture. We'll discuss about this arrow as well. We had done this arrow earlier with the earlier setup, right? The PCC arrow, converting the getting rid of carbon hydrogen bonds to copy the carbon oxygen. This PCC. We'll discuss that in later. So anyway, there is a symmetry like this between the primary alcohol, second aldehyde, and the carboxylic acid. They are in the same R group. You can just convert the CH2OH to CHO and to C double bond OH. That is what we are doing here. Converting CH2OH to CHO and to C double bond OH. Another relationship between the 3 guys, like in the earlier case. Right? Let's think of what are the reagents we are supposed to add to do these conversions. So basically, right? I would say, right? This is the compound with the highest oxygen state available. This is the compound with the highest oxygen state, highest number of CO bonds, the oxidized species. I would say this is the species with the greatest reduced form. Greatest reduced form is this, right? More number of hydrogens are there. So this is the reduced form. This is the oxidized form, the complete oxidized form and the complete reduced form. I would say like that, right? I'll say this is the complete reduced form, is the complete oxidized form, right? Okay, so we can use the H plus KMnO4 or H plus dichromate. We can use the H plus KMnO4 H plus dichromate to convert the guys to the complete reduced form. Convert the guys to the complete reduced form. H plus KMnO4 or the H plus dichromate. So those are referred to as strong oxidizing agent. Strong oxidizing agents. Those can be used to convert the guys to the complete oxidized form. Here as well, you can convert the aldehyde to the carboxylic using the same strong oxidizing agent or H plus dichromate. Right? Okay. So the complete reductions can be done by the reagent, right, which will hydrogenate the polar 5 bonds, which will hydrogenate the polar 5 bonds. The complete reduction can be done by the reagent which will hydrogenate the polar 5 bonds, that is lithium aluminum hydride. So you can use the lithium aluminum hydride to provide the hydrogens to hydrogenate the polar 5 bonds to come up as the primary alcohol. This is one reagent you can use. Or else another reagent is available, that is same like lithium aluminum hydride. You can use the sodium borohydride. Some other reagent. Sodium borohydride. So like lithium, you have sodium, the group 1 guy. Like aluminium, you have boron, group 13 guy. Sodium borohydride. Normally that is used in methanol medium. So those reagents can be used to convert the aldehydes to alcohols by hydrogenating the hydrogenating the polar 5 bonds. So for this conversion as well, you can use the lithium aluminum hydride. You use the lithium aluminum hydride, but not the sodium borohydride lamine. Remember that. You can't use the sodium borohydride in this case. So sodium borohydride is referred to as a weak hydrogenating agent. It's a weak hydrogenating agent, so you can't use that. Sodium borohydride can't be used for do this kind of a greater reduction. This kind of greater reduction can't be done by the sodium borohydride, but the lithium hydride is able to do so, right? So for this kind of a smaller reduction, both the reagents can be used, but for the reduction with great extent, only lithium aluminum hydride can be used. So basically, I would say, right, this lithium aluminum hydride and the KMnO4 dichromate as reagent of corners. See, if you write the KMnO4 dichromate, right, that will guide you to the corner, the greatest oxidized form. Even you have to add KMnO4 dichromate to this one or to this one, you will end up with here. Reagent of corners always guides to the greatest possible oxidized form, the KMnO4 dichromate. The lithium aluminum hydride it is again a reagent of corners. So it will guide you to the highest reduced form, complete reduced form. If you add the lithium aluminum hydride to the aldehyde or to the carboxylic, you would guide to the greatest reduced form, the primary alcohol, reagent of corners, lithium aluminum hydride and the dichromate and the KMnO4. Right? Some symmetries there with this one, with the region of corners. Then you see the bridge. Between these guys by the PCC. The bridge between these two guys are formed. PCC is pyridinium chlorochromate. You had reduced the oxidizing ability of the chromate. Oxidizing ability of the chromate is reduced by the PCC. PCC is pyridinium chlorochromate. So basically, when it comes to chlorochromate, this is a chlorochromate. This is chromate, no? CrO4 2 minus. This is chromate, no? So by releasing these oxygens, the chromates participate in redox reactions, no? So chromates, when in acidic medium, convert to Cr3 plus, no, as an oxidizing agent. So those chromates convert to Cr3 plus. So releasing oxygens, right? So those released oxygens are the ones which will use to oxidize the other species. That is how the chromate is doing its oxidizing agent ability, that process. But with the PCC, what they have done is they have removed one of this oxygen and came up with some chlorine. O minus is kind of a 7 neutron system at the valence shell. They had replaced that thing with another 7 neutron system, chlorine. So this is the chlorochromate. So you have reduced the number of oxygens appearing with the chromate, so that the oxidizing ability, so that power will be weakened by converting the chromate to chlorochromate. That is why you are able to stop at this level. So using the pyridinium chlorochromate, you can stop the oxidation at the aldehyde level. If you had used just the acidic chromate or the acidic dichromate, this will convert up to here, but you can stop the oxidation from here if you are to use the PCC. That is the usage of PCC, right? So with this, we clearly see, right? We clearly see the relationship between these three guys. So if you are with only with one thing, you can come up with the other two. අර මේකෙත් ළමයි අර මේ effect එකම දිනනවා. මේ effect එකම මෙතනක් තියෙනවා. හරි? ඔයාගෙත් ඔයා මෙයා ඉන්නවා කියලා කියන්නේ you can produce the other two. If you are with the primary alcohol, you can produce the aldehyde by adding PCC with the same R group. You can produce the carboxylic acid with the same R group by adding some greater oxidizing agents. So if you are starting with this one, right, aldehyde, you can come up with the primary alcohol with the same R group by just adding lithium aluminum hydride, and you can convert the aldehyde to the carboxylic acid by just adding the strong oxidizing agents with the same R group, right? So if you are starting with carboxylic acid, you can convert that into the primary alcohol with the same R group by just adding lithium aluminum hydride. And if you are starting with carboxylic acid, you can convert that same thing with the same R group. That carboxylic with the same carboxylic acid can be converted to the aldehyde with the same R group by first adding the lithium aluminum hydride to come to here and then adding PCC. So that means if you are with only one of these compounds, that means you are with all the three, because the inorganic reagents will be able to convert those starting compounds to the other two. එක්කෙනෙක් ඉන්නවා කියලා අනිත් දෙන්නක් ඉන්නවා කියන හැඟීම වට ඇති වෙන්න ඕනේ. ඒ වලින් කන්වර්ෂන්ස් වලට යන්න පුළුවන් කියලා දැනෙන්න ඕනේ. Right? Okay? Then such kind of same thing happens with the secondary alcohols and the ketones. Ketones are the ones with 2R groups. Ketones are the ones with 2R groups. So ketones with the same 2R groups can be produced by the secondary alcohols by doing this kind of same process, right? So this can be done. The ketones can be converted to secondary alcohols by just hydrogenating the polar phi bonds. That is that can be done by the lithium aluminum hydride, dry ether with H plus H2O, or you can come up with sodium borohydride methanol. Right? So this conversion can be done even the PCC. So PCC is able to oxidize only one carbon hydrogen bond. PCC can be used to oxidize only one carbon hydrogen bond. So that can be done. One carbon hydrogen bond, this thing can be oxidized with the use of PCC. So you can use the PCC here, PCC, as well as the strong oxidizing agents, because you don't have any other hydrogens to oxidize afterwards. So only one hydrogen is there. No? So this is the corner of the compounds with 2R groups. So regions of corners can be also used. So H plus KMNO4 or the H plus dichromate. Any one of those can be used. Just complete this table now. So you can't think of any kind of oxidation with tertiary guys because you don't have any carbon hydrogen bonds there. So simply just complete this thing, and we can then do some few more conversions there. Yes. You can't convert the carboxylicid to the aldehyde. එහෙම reagent එකක් නැහැ. ඒතර ඔයාලා carboxylicid aldehyde එක convert කරන්න ඕන මොකද කරන්න ඕනේ? මුලින්ම carboxylicid මෙතනට ගෙනල්ලා තමයි PCC දාලා aldehyde කරන්නේ. අර ඒ කතාව මෙතනක් තියෙනවා මේ. මෙතන bridge එක හොඳට ඔලුවේ තියාගන්න. bridge එක මාර වැදගත්. හරි? මේකෙත් මේ bridge එක මාර වැදගත්. මේ bridge කරන්න මෙතනින්. මෙන්න sorry ඔය bridge එක යන තැන මාර වැදගත්. හරි? දැන් මෙතන තොර ප්‍රශ්නේ නේ මේ. ඔයාලට alcohol එක කෙලින්ම RNH2 කරන්න බෑ. There's no such reagent. alcohol එක RNH2 කරන්න නම් මුලින්ම RBR කරලා තමයි RNH2 කරන්නේ. වැඩේ කරන්න පුළුවන් කොහොම හරි. හැබැයි there's no one step reaction there. හරි. ඒ වගේම ඔයාට RNH2 එක කෙලින්ම alkyl කරන්න බෑ. First you need to convert to alcohol and then only you can convert to the alkyl. හරි. ඒ වලට double arrows නැහැ. දෙපැත්තටම යන්න බෑ. හරි. ඒතර එහෙම දෙයක් තැනක් තියෙනවා. ඒතර එතන මේ bridge එක වැදගත්. bridge කරන තැන. bridge කරන තැන නිසා තමයි ඔයාට හැමෝගෙම හැමදේම එක්කෙනෙක්ගෙන් හැමදේම හදාගන්න පුළුවන් වෙන්නේ. හැමෝගෙම හැමදේම හදාගන්න පුළුවන් වෙන්නේ bridge එක නිසා. මෙතන bridge කරන්න මෙතන. ඔයාලා කවුසෙද එක සැරේ ගන්න බෑ. කවුසෙදෙන් aldehyde එක සැරේ ගන්න බෑ. මෙතනට ඇවිල්ලා PCC දාන්න වෙනවා. right? Anyway, this is just all of these guys have the same R group. හරි එකම R group. අර මේක තමයි එකම R group එක තියෙන. මෙතන CH3 නම් මෙතන තියෙන්නේ CH3. අතන CH3. මෙතන තියෙන්නේ C2H5 නම් CH3CH2 නම් මෙතන CH3CH2. මෙතන CH3CH2. එකම R group එක තියෙන primary alcohol එක aldehyde එක carboxylic එක අතර තියෙන relationship එක තමයි මේ කතා කරන්නේ. හරිද? There's no region like this here. right? bridge එක මාර වැදගත් PCC කරන්න. හරි? right. හරි. අපි මේකෙන් questions දෙක තුනක් හදමු ළමයි. ඒකට පොඩ්ඩක් ඔයාලට මේක set වෙලා වැඩි නවත්තන්න පුළුවන් නේ. හරි. දැන් ඔයාලට example එකක් දුන්නා මම ඔයාලට මෙතනින් පටන් ගත්තොත් දැන් මේ sorry මෙතනින් පටන් ගත්ත කියලා මේ වගේ තැනකින් පටන්ගෙන අර මේ කොන වෙනකම් යන්න පුළුවන් වෙන්න ඕන. හරි? නිකන් අර CH3 CH2 Br ගෙන් පටන්ගෙන you could end up with CH3 C double bond OH. CH3 CH2 Br ගෙන් පටන්ගෙන CH3 C double bond OH වලින් ඉවරන තරමම ගෙනියන්න පුළුවන් වෙන්න ඕන. හරි? එකම රේෂිප් එක මේ තුන දෙනා නැත්නම් අර RNH2 කින් හරි පටන් ගන්න කවන්නේ අර කොනටම යන්න පුළුවන් වෙන්න ඕන. RNH2 මටන් ROH එන්න පුළුවන්. ඉතින් අර මේ සර්කල් එකට යන්න පුළුවන් වෙන්න. නැත්නම් මේ පැත්තෙන් පටන් ගන්න aldehyde එකෙන් හරි මොකෙක් හරි පටන් ගන්න මේ පැත්තට ඇවිල්ලා මේ වටේ යන්න පුළුවන් වෙන්න ඕන. හරි? ඒ compounds හදාගන්න පුළුවන් වෙන්න ඕන. මෙහින් starting compound මේකට පටන් ගන්න ultimately මේ වගේ RNH2 එකක් වුණත් හදාගන්න පුළුවන් වෙන්න ඕන. That is our goal here. shape නේද? හරි. අපි එහෙනම් questions එක දෙක තුනක් කරමුද? ඒක පොඩ්ඩක් මේක set වෙන්න. හරි. Let's do some. හරි. නිකන් මෙහෙම බලන්නකෝ. මේ compound දිහා. I'll do the first one to get some idea what you need to do here. Now you can start with here and you need to come up with this one. First see the carbon chain. You are with 3 carbon chain. You are with 3 carbon chain. Okay. First see the carbon chain. And see the difference. So with the third carbon here, with the third carbon here, you are with a Br. Now you are with a aldehyde group. So Br should be converted to the aldehyde group, and the same R group is appearing. Same R group is appearing, right? So this is the functional carbon with you. This is the functional carbon of your last final compound. So what you need to do is just converting this Br to the aldehyde. So you know the Br and the aldehyde both are related by the alcohol. Br is related to the alcohol, the OH. This aldehyde CHO is related to the OH. Both are related to the OH. So if you can build up some OH here at the center as an intermediate, so you can come up with this one. So let's do the stuff. So you can convert this one to CH3 CH2 CH2 OH. We can convert this Br to the OH by adding NaOH aqueous NaOH. That is a simple reason, right? So convert the Br to OH, you are adding some OH. Br to OH, you are adding some OH, right? That's it, no? NaOH. Right? So then this OH, you are with the same R group. This R group is there. This guy is also with the same R group. So converting the CH2OH to CHO, converting CH2OH to CHO, you can add the PCC. The PCC will convert the CH2OH to CHO with the same R group. So that is how you are supposed to do this kind of a conversion. So in your conversions, they will give you only these two. You need to come up with like this. You may the steps may involve 4 or 5 steps, right? 4, 5, 6 steps may involve at the total conversion, but it's a very simple conversion, right? That is how you are supposed to think of these things, right? Let's come up with another one, right? Just try to do this second case. මේක ලියාගෙන මේකත් ලියන් කරන්න බලන්න. මේක කරන්නකො එහා පැත්තට. Do this one. Right. First, think of the carbon chain. 3 carbons are there, 3 carbons are there. And the functional carbon won't change. That is all the same. Yeah. Okay. Now what you need to do is just to convert this aldehyde section to NH2. That is what you need to do. See how to do that. Converting this aldehyde, this section, to this. So what can you do? First, so this is coming from the right hand side picture. This is coming from the left hand side picture of your note number 2, no? So the two things are connected via the alcohols. Two things are connected via the alcohols. The right hand side of the picture and the left hand side of the picture of the note number 2 is connected via the alcohols, right? So let's just convert this into alcohol. Then we can think of producing this one. So aldehydes can be converted to alcohols. Aldehydes can be converted to alcohols with the same R group. See? The same R group, right? Same R group. The CHO can be converted to CH2OH by just adding lithium aluminium hydride. right now. Then now your task is to convert this OH to NH2. The task is to convert this this OH to NH2. See, the things are already done. So just converting the OH to NH2. For that, the left-hand side picture of the node number 2 can be used. The relationship between the OH, NH2 and the Br. So OH can't be directly converted to the NH2. Before that, you need to convert that thing into the Br. There is no such reaction directly to convert the OH to NH2. So first, convert that into the Br with the CMR group, right? You have the CMR group, so you can convert to the Br. Then that Br can be converted to the NH2. To convert to the Br, you should add the HBr. Convert to the Br, you have to add some Br, right? So just add HBr to provide the Brs. To convert Brs to NH2, you should supply some NH2s. That means that can be supplied by NH3. NH3 will supply NH2. That remaining H will remove with this Br as HBr molecule. The other NH2 will connect with the carbon. Right? So that is how we are supposed to do a conversion. Right now. Right? මම ඔයාලට තව එකක් කරමුද? තව එකක් කළාම එක්සාම් මේ වාට තව හෝම්වර්ක් ටිකක් දෙන්න. හරි? එකක් කරමු. කළා තව හෝම්වර්ක් ටිකක් දෙන්න. එතකොට ඔයාලට මේක සෙට් කරගන්න පුළුවන්. හරි? The third thing. මෙහෙම. Sorry. Let's come with CH2C. Need to convert it into Br. මෙහෙම යන්නකෝ. අර වගේම එකක්. කොහොමද මේක හිතන්නේ? අර වගේම හිතන්න. right? මම මේකත් කරන්න ළමයි ඊට පස්සේ ඔයාලට homework ටිකක් දෙන්නම්. right? එතකොට බලන්න. මුලින්ම carbon තුනක් තියෙනවා. This guy is also with 3 carbons. This is the functional carbon. Yes. The only change happens with this thing is the same R group is also appearing, right? Functional carbon එකම R group එකක් තියෙනවා. Only change we could see is this carboxyl acid ultimately converted to a amine. This comes from the right hand side of the picture. This comes from the left hand side of the picture. Those are connected by the alcohols. So what we can do? So first, you can convert this into the primary alcohol with the same R group. The R group is alcohol convert करना. ඊට පස්සේ alcohol එක එක සැරේම NH2 කරන්න බෑ. First convert that into Br with the same R group. Then that can be converted to the NH2 with the same R group. So for this thing, you can add the reagents to convert this into this lithium aluminum hydride again. It is a reagent of corner, dry ether medium, D is okay. Number 2 H plus H2O. This is how the lithium aluminum hydride is added. Convert this to this, you come with HBr. To do this thing, you can add the NH3. Right now, තියොන්න අපි කන්වර්ජන්ස් තුනක් අපි ඔයාලත් එක්ක කරා මම තව හෝම්වර්ක් ටිකක් දෙන්න. right? ඒකට ඒ ටික කළා මට එවන්න. right? ඒ ටික කරලා අපිට WhatsApp එකට දාන්න. නේ? Okay. So just do those conversions. හරිනේ ළමයි තියෝ ටික ඉදිරි කරන්න. right? So එදා ගන්න. හරි just take a screen capture there. හරිනේ මම ඕන පිටුරක් දාන්නම් ඕන. right? හරි එහෙනම් let's wind up at this stage. අපි මෙතනින් අපි වැඩි නවත්තමු අදට. We had discussed the note number 1 and 2 to the questions, right? Then we'll start with the note number 3 from the next class, right? Then goodbye then. See you next week.